Wow. This is a new. It's kind of admitting that it can't do it here. Might be more practical to perform it using a more robust mathematical software. Yeah, but I don't have that. Anyway, what did it say? Yes, it is gave up. Stop asking me these difficult questions. But then in a polite way. So this was m00 plus 2m01 t times 2m11. Yes, that's what I said. Okay, that times that, yeah. And then minus that times that divided by that squared plus that squared to the power 3, 2. I guess that it repeated it correctly here. 0, 1, 1. The 0, 1 is that one. And then this plus that squared. Okay. What the hell is this, you know? M to the power 10? No, it's M to the power. It interprets this as to the power for some really strange reason. Let's try underscores. Still did not work. I think it calls M01 is changed into L1 and the M00 into M0. Well, that would still work then, but not what we asked for. Can you like talk LaTeX to this thing? What happens if I put that around it? Nope. Did not like that either. Ridiculous. I have the feeling this is not going to be 0. It's probably just that has to be equal that. This is the bloody determinant of the matrix. That's not 0. That's minus the determinant of the matrix. The matrix is definitely invertible, so it's not a 0. So then it's actually that this has to be 0. Yeah. Is that a good reasoning? I think so. How do we call this again? This is the numerator and this is the denominator. The numerator needs to be 0. Correct. I could just copy this, but I can't. Yeah, well, that's not very making things easier. Anyway, I don't think that 1 0 minus 0 0 1 1 can be 0 because that is minus the det m, and I'm pretty sure that m is invertible. Well, it should be. So then the other thing has to be 0, this one. So then the second equation must be 0, which results in a simple equation for t. You think we can safely kick Gabriel out? Because even if it isn't a bot, I mean, what the fuck, dude? Why do all the psychopaths end up on my stream? Well, not psychopath. How do you call someone who has what's the word? T is this. Looks about right. Yep. To vary this in the unrotated case where x0 equals the vertex, both m10 and m01 are 0, so that this is 0 minus 0 divided by m11 squared. So t is 0, and that's correct. Yes. Don't like it. Small. Nothing really. I'm just playing around. I mean, I can draw it in my what is it? Draw it in my graph and then see that it fits, which will give me a good feeling. Do you still have to values of the in terms of the blah, blah, blah. No, I'll just ask a simple question. There, enter. I pressed enter. Let me show you. So, blip. This is rotated 90 degrees. So the vertex is here, and if we are understanding stuff, then this V here should end up there. Currently, it's just where it is when we rotate this thing. No, currently it's just nonsense. It is at the right place when I put when we set theta to 0. So I've got this code working for theta 0, an unrotated case. Actually, well, and partly for rotation in the meantime, by the way. But in this case, you see the everything else is correct as well. So x0 is just an arbitrary point. And then, now this is still not a Bezier curve. It's just a, well, it's my curve. I went to bed and then I was thinking about it while in bed, and then I came up with this curve. And now, the last 2 days I've been trying to analyze that thing, so I understand everything about it. See, the vertex is clearly here, and then the width is given by this distance, where this distance is, well, the distance that you see for being one higher than the vertex. So the vertex point here has a y value of -3, and then one higher, you sit at -2, and then drawing a horizontal line, cuts it there and there, and that means that the width here is between, well, from 5 to 6, which is 1. So W is 1 here, and that's what we call the width of the parabola. And then I changed it off stream. Yesterday when I stopped streaming, I continued a little bit, and I just added the correct rotation. To calculate cosine and the sine of theta, and then I used that as my matrix. It's actually M00, M10, M01 and M11. And then you can rotate the thing. So for example, if now I set theta to, well, let's say a quarter times pi, so rotate 45 degrees. Then you just get the exact same thing, but then rotate it around x0 by 45 degrees. They didn't teach you this at school, because rotated parabolas. And then I thought, well, it would be funny to just draw this V also right there at the vertex point. But in order to be able to do that, I have to calculate it, right? And we are calculating it now by saying, well, the vertex point is defined by that the curvature at this point is maximum. You see, here's almost a straight line, here's almost a straight line, but then it starts to curve more and more and more and more, and then the maximum curvature occurs exactly there. And you can, well, I found on yeah, this one, that's just the old place. So I found on Wikipedia that what the curvature is for any parametrized curve, meaning x is a function of t and y is a function of t, and then you vary t, and then you get points, which now can run like this. It's not necessarily a function anymore. And then the curvature is given by that formula, and then we take the derivative of that, because then we find the maximum curvature. And since the formula is for the signed curvature, it can be both negative or positive or negative. I guess if it's the other way around, then it's the sign has changed. But it doesn't matter, the derivative is still going to be 0. So the derivative of the curvature at this point is the only point where it is 0. Because the left and right, the curvature is less, you know, going more towards a straight line. From that then we could conclude that it is for the t value, this t value, or these are just the matrix elements that I'm using, but the actual elements that we were using, oh, it's did recalculate it. The actual elements that I'm using is this. Let's just check it. Well, I hate to continue working with something that is wrong. So I have to keep checking everything to make sure that what is on my screen is the truth. So yeah, A is M00. which, well, this is A. I think I have A here, B, A, B, C, D. Yeah, so A is cosine theta times W to the power 2, 3. Cosine theta times W to the power 2 third. Minus 2 times S times the sinus of theta times W to the power minus 1 third, or divided by W13. 2 times sine theta and S divided by 1/3. So that's correct. And then B is minus the sinus of theta divided by 2 thirds. Yep. And C is sinus of theta. Well, just cosine changes into the sine, and sine changes into minus cosine. So this cosine becomes a sine, and this sine becomes a cosine, and the minus sign becomes a plus. And here we, well, actually have the same thing. The sine becomes cosine, and the sign is changed. Yep. So this is correct. And it even continues. M00 is that one, yep. M01 is that one, correct. M10 is that one. And M1 is that, yep. These values express the elements, blah blah blah. Okay, now I want you to fill it in, asshole. So why stop here? So what happens if you fill in those values? Formula. Okay. Okay. Formula of T. That we found lost the T where we are in the vertex point. Now what? Well, can I assume that it did that correctly? I like this one so far, but now it stops giving me formulas, which is really bad. And everything disappeared, as usual. Now we only get to see one. Dude, just fuck off. Gotta be kidding me, right? Is that your result? Minus S times W to the power 1/3. Wow. I must say, it kind of lost me here. I guess cosine times sine drops out. I have a minus cosine. Oh yeah, well, the W to the power 2/3 times the W to the power minus 2/3, they drop away. And then we have this a minus and a minus drop away. Then we have a cosine times the sine. And here we have a minus a sine times a cosine. And again, the W's drop out, so that falls away against each other, yeah. So then what you are left with is minus 2s sine, what is that? Oh, this minus, yeah, okay. So this minus here, the 2s comes from there. This minus drops against that minus, and then sine against sine is sine squared. And then minus 1/3 minus 2/3 is minus 1. And then the same thing here for the, let's get the minus still there. We have cosine, so that is again confusing. It's still, yeah, because see the plus here, but it's a parenthesis around it. So this minus survives, 2s in front of it, and then cosine squared divided by w, okay? And that's 1 and that's 1. So then you end up with a minus 2s w to the power minus 1 divided by 2w that. 2 drops out, minus survives, s w is then minus 1 plus 4/3, so that is, yeah, 1/3. That's actually correct. Right. Minus S times W to the power 1/3. Yep. And then I have to calculate I think just this. Let's make a Laplace for those. So x is function of t is double input t. I would say it doesn't look correct. What the hell? It's in the neighborhood of the vertex, that's for sure. But I would say the vertex is there, not there. It's actually Vx is exactly the same as the x0. I don't think we have the vertex here. Dang, what the hell? I'm confused. Let's change theta back to 0. Now it's correct. it did not just copy the x coordinate of x0. Going to add some random values. All random. Keeps working. On the rotated case, it is correct. What about the rotation by 90 degrees? No, also looks correct. Looks correct, I would say. I mean, if this is not the vertex point, then what is this thing doing here? And then I meet the red cross. And I set the width to... That's kind of strange though. I set the width to 1.5, right? So from there to there it should have been 3. It's totally not it. Or am I crazy? I really need to be able to have some slider and just continuously change it. In the end, that's the only going to be the only reason that what is the word? I'll say defense, that I put all this time into it instead of using GNU plot. Yeah. I can draw a few, maybe a few different ones. Bullshit. Yeah, what's this with these lines here, man? Because I'm drawing it like this, and then we could just continue drawing there. But yeah, it grew above my head. I think it was so difficult. So normally I don't give up very quickly, but in this case I have the feeling that my age might overtake me. So it's kind of I'm getting more and more stupid every day when I get older. So I think that if I continue with the Vulkan engine, then it's going to take so long that I'll never be able to finish it. If you get what I mean. Let's say I can't finish it in 10 years, and in 10 years I'm senile, so I wouldn't be able to work on the Vulkan engine at all anyway. It's like an ever-moving horizon that goes further and further away. Then, when I let's say when I get less, when I get older, less smart, then I work it will take me longer to finish something. So in this case, I would never finish it. If you get what I mean. So it's kind of pointless to continue then. That's the feeling that I have. Okay, so we're trying to find out now why it's drawing those lines. Well, the only thing I do is draw single lines. We add a line and we draw that line. Why the hell would that draw a random line that I never asked for? That's strange. This adds, this calls draw on whatever is in lines, which is obviously a line, the unique point over a line, and now we call draw on that. So that would be this one, which then calls draw with the line pointer, which is this one. Which does a pushback of the pointer to the line, and then we call draw on it. So this calls draw on the layer region, which is this function, apparently, I think. It's not a Wordle function, is it? Draw. Probably not. No, just this function here. And the first time we call this, it's going to call redraw. You enjoyed my Vulkan streams? I don't think anyone was following it. It was, well, it is kind of super complex. So there's absolutely nobody who was understanding what I was doing. So what's the difference? What's the difference with this then? Worst case scenario, you do understand what I'm doing now. Or I'm wrong, of course, and you did understand what I was doing, but well. Redraw. Damn it, man. What is happening? I still don't get it. So redraw function on the layer region, which is this one, which calls draw, which does call do draw probably. With this virtual to draw of the line, which starts with a move to. So yeah, it's completely beyond me how it's possible that this draws a non-existing line, really. Unless I literally add this. Could add a line if it's just adding a line from here to there, okay. Duh. My freak thing is red. Oh, not everything. This is not red. What? Still very strange. Weird things are going on here. Weird things. Let's make it 10. How the hell can those lines be longer than the square root of 10? These parabolas are being drawn like tiny little pieces. Tiny little... Oh, wait a minute. I'm talking about pixels at this point. Yeah, okay. They're very tiny. Now we are talking about line length here of in pixels of huge. Okay, this is maybe a few hundred. So let's say anything longer than this, which is like say 100 pixels actually. Longer than 100 pixels, and this is the square, so 10,000. Yeah, okay. So now we see that it is being drawn as a line. It's just red. I mean, the only way it can be red is when I set a color right there before I draw that line. I'm convinced that this is an actual line. So it goes wrong the moment the line is being constructed. Where this is the case. So this should not be true. I can add an assert stating that this should not be true. Okay, it must be less than that. Less than or equal. But, yeah. And now we're not interested anymore in... Oh, actually I am. No, I am not. I'm interested in that when that happens, which is during construction. So if a line is constructed where the length of the line, oh, now we're going to assert for the bloody grid. So I have to turn on the grid. I think the grid is the only thing that was turning red as well. Probably not what I wanted. No grid. Yep. And then we crash there. Yeah, no, where, you know. This is from big X, reasonable Y, to negative, yeah, okay, that's probably this first long line here, at the end of the first parabola. Up, which is being constructed in make unique, which is being called from plot add curve. Oh, Yeah, and that's what I mean with senile. Now I realize what it is, and I think, oh God, why didn't I just immediately understand that? Wait, no, worse. For a moment I thought I understood it, but it can't be it. Because I'm calling this in a loop. Or are we? Points 1602. Points are passed to add curve up. This curve points to. Oh. Okay, yeah. Probably should remove the assert again. Line.h. Yeah, that's just the only thing I added, I think. So you can see it does rotate around x0, and well, looks like the vertex point is correct now. For these angles anyway. So let's try an angle of m pi divided by 6. Yeah, and again, my eye disagrees. But maybe you understand now why. The reason is that it is sheared. Or what is it? No, scaled. The x, this distance is 2, and this is tiny, a little bit smaller. So by eye it looks like it should belong here, but that's not the case. This is the actual vertex point. You calculated correctly. I don't not want to show it distorted this way, because then I cannot check it. So we want to have the the distance vertically here the same in pixels. How the hell will we do that? You see also that the width is not the same. No, this is clearly, this thing is wide. If you compare that to this thing, then it's less wide. It's vertically compressed. Now the only way I can think of is I can't think of it. No. I could set the no. Well, yeah, we can hack something, I guess. But what if you really want to do this? Like set the ratio the same. I think I have to add support for that. So I could add a boolean somewhere which says make the ratio the same for the x and y. And then it has to compress, I guess, the rectangle, this rectangle, such that that ratio becomes equal. So in this case, the y is compressed, so we have to compress x as well. So this thing must be moved inwards until it is a square-ish thing. Which can only be done after we have the x and y range, at which point I think I already have that rectangle defined or not. So I have to change the rectangle after the fact. Let's see. Talking about plot, let's have a look at plot. Plot should have a set range here. At the moment we have both ranges. Then I can change my stuff. But if I don't call set range, then it's also doing something. I think it's then doing something. Yeah. At the moment, I do. This is the function, isn't it? Axis geometry. The axis geometry returns the rectangle that we were talking about. Oh, the question is, do I already have my range values here? So when is this called? During the constructor. Yeah, I'm already using it to set the title. Plot area geometry is used again. So that, but well, yeah, that's kind of okay, I guess. Because if I would shrink one of the sides, I don't necessarily want to move the title. Not at all, probably. Or, yeah, I don't care. So I think we can do this afterwards. X and Y level, same thing though. It's not gonna move along. I think this is the canonical function at which everything must be there. Let's have a look at add to layer. So maybe I should delay the calculation of the position of the title as well to this point. Here I'm just drawing the title. Yep. Gemoved. It's not very nice. I want to set a position instead of moving it. Call this rel, like Cairo does. Let's just add accessors for everything. Lens. So now I can change the plot area geometry, and then the title is adjusted afterwards. Do I have another plot area geometry that I'm using? Probably. No, it's already being drawn here. So. And I'm using it anyway. Okay. Loads of places. Okay. That means that's not bad. Means I can just change the plot area before this point. Or let's add a boolean here for the keeping the ratio intact, or what is it? Keep ratio, yeah, I don't know, keep ratio, whatever. And then if that's set to true, now if the ratio is set, then I'm going to change it. Let's begin with just changing it. Plot area geometry. Something. The grid. The grid is going to adjust itself also automatically. I have to update this as well then. I guess we'll just do a set geometry after the fact. This is before drawing, obviously. So I only have to change whatever the constructor thought was correct. Which is using the geometry. It's been passed to multi-region. No, it's not. Use it to set the geometry and the tick length. Yeah, no, let's not change that. Draw grid, not changing that either, and the grid itself must have a new geometry. Grid, set geometry, also changed. I don't know, might work. So now I have a set geometry. Let's just try something. Plot area, set geometry. You can do a rectangle. Can't even change this. Unbelievable. Nope. I didn't do anything. Except that my title is in a weird place. Huh? The grid is also still off. What is happening? Why is this not drastically reduced my plot area? Super strange. What the hell, man? Plot area. Oh. Yeah. Okay. Brilliant. You never get here. I don't set keep ratio to true. Which would be very nice and dandy if my title wasn't fucked up. So why is my title fucked up? Because I do this now and that is not correct apparently. See, now it is on top, and if I do that it gets here, as if the offset is 0. What the hell, man? So before we had, go here, the title gets a position set during the constructor. plot area, and that would be this one. Except that I'm calling that one, but it should be the same. Because the title here is a text which gets passed, pause in style, text pause in style, text for first the style now, and then the text, and then the pause, and that's it. And rel move to sets pause x and y. I better call that one, which is constructed from the second and third argument, which is this x plus half that. And plot area geometry offset y minus title style offset. And then we have to remember that, and we should do that because I'm also passing the title style. And in this case we have offset x plus a half time with plot area, oops, must be the same thing. Plot area will do that y minus Yep, okay. This was missing here. Lop. Offset is 0. Yep. Okay, and then that's also missing here. Update. And then now it is fixed. Yep, and then we call add to, or what was it? Add curve. No. Plot add point, add text, add point, add text. Add to layer. This one. Why can I not find it? Add to. There it is. Just add it immediately at a very bloody start. Finally, okay. Now I think it did compress it. The grid compressed with me. The title is centered again. Well, I can't say the same thing about X here, but yeah. Probably have to do that as well then. Now, do these things look like squares now? Not exactly. I think they have to be tiny a little bit less. white still. It would be more like the golden ratio thingy. Obviously, no, not really obviously, but why not try that? Blip, lumbling, pointing, gring. No. At most is now not wide enough, I think, but square enough. Now it is pointed at the vertex. I'll say I'm not convinced. It's still not exactly at the vertex, is it? Man, oh man. I think it's hard to see because of this line here. Let's remove the other parabolas. Get a bit in the way. Yeah, now the grid gets in the way. Or it's not at the vertex, either. I mean, I'm really trying here to say that it is in the vertex. Nope. Can't say that it's in the vertex. Or is it? What do you guys think? Feels like a whole pixel next to it. But then again, yeah, maybe it is. I mean, I guess it has to be. Yeah, okay. Okay, so Yeah. Yeah, it is. If you sealed off the access, you just look at this piece, squint your eyes, then I can agree that this is the vertex. Cool. Still need to fix that ratio thing though. I have to think about that. It's not easy. Can't just use 0.75. No, I have to calculate it. I did not add a parabola. No, we added a lot of stuff. Not a parabola. I'm more like using it now at the moment. But the goal is ridiculous as usual. Anyway, if we want to keep the ratio, then what does that mean? I want it to be the pixels must be the same number of pixels per x and y axis unit or something. Yeah, it's fortunately not as difficult as I thought. We do just pixels per x unit is, well, that would be geometry dot width divided by the x range, because the x range fits exactly on the width of the plot area. Range of the x-axis dot size. Oops. And then we do that for the y value. Yeah, it's the same thing except height. And then we have to decide which one we're going to change. So if the number of pixels per one, do I change the width? I could just calculate the factor and then look at if the factor is larger or smaller than 1. So let's calculate the factor. The factor is double. either this or the other way around. So I'll just try it out. I would almost say I did not recompile it. But let's just say that I did it right. I did it right. Yep. So cool. Now we have a ratio boolean. What is next? I think I'm gonna cook some dinner for Carlo because Carlo is not complaining, but his stomach is making noises. How can one concentrate? And someone's stomach is making... No, it's not making noises. I'm just making it up. But it's like this time that I feel like maybe I should eat something. What is the next step? I could draw my dashed thing is again like a dashed line, like so and so and so and so, and add my W. But what does that gain me? Not much. I think I'm not going to do that. It's just a waste of time. What I do want to do is demand that this parabola goes through another point. Let's call X0 P1 because reasons. P1. Do I need a subscript 1 somewhere? Or I have that. Subscript 1 coming up. Good. Now I want to have a point P2 defined as well, and then have my curve go through that point. And then the question is, how do I determine the matrix M such that that is going to happen at t equals 1? So let's think of a point. Let's say the point that is already almost on it. This point. Well, -2, -4. Sorry, 2 -4. Now can already show the point. It's a fixed point. Oh, it's not on the curve. No, it's not. Right, so now we have to adjust something. Yeah. Opimanu says do a commit. It's probably a good idea to do that at this point. Let's first go here. Right. Back to ChatGPT, but I'm going to eat first, I think.